To factor, we'll look at three ways of factoring today. To factor, we have the greatest common factor, or GCF. The second one that we have is reverse FOIL. And then the last one that we'll look at is factor by grouping. For our first, finding the greatest common factor, the question says factor completely. So we have 5x minus 10. Now when we look at that, we're looking for a number and or expression, including variables, to which we can extract that goes into both 5x and also into negative 10, so that we don't have anything left over or a remainder. So when we look at these two expressions, 5x and negative 10, 5 goes into 5x evenly, and it also goes into negative 10 evenly. So what we do is factor out a 5. That's called the greatest common factor. It's common to all of the terms in our expression. Then what we do is take 5x divided by the greatest common factor, and we're left with x. If we take negative 10 and divide by the greatest common factor, we'll get negative 2. So when we can check our work, we use the distributive property and distribute. 5 times x is 5x, and 5 times negative 2 is negative 10. So as long as we can get back to what we originally started with, then we can manipulate the equation the way that we need to. So this is factoring completely using the greatest common factor. Let's look at reverse FOILing. So the question says to factor completely, and we have x squared minus 4x minus 21. Well, we look to see if there's a greatest common factor first. If we see that there's a term that's common to x squared, negative 4x, and negative 21. Now, the only thing common into each one of those is 1. So that's the only thing that's common, so we don't need to factor out a 1 as a greatest common factor like what we've done in the previous example. So now we look to reverse FOILing. And FOIL stands for the first term, f, the outside term is o, the I is the inside term, and the L is the last term. Now you can do that with quadratics. Always have the quadratic written from descending order, and a quadratic has a power raised to the second exponent. So when we look at factoring, we look at the first term first, x squared, and we decide what are the factors of that. Well, the factors of x squared are x times x. So we put that in the first and the first brackets. And then what we do is look at the final negative 21, the last term. Well, we want to find the factors of that such that when they're added together, we're going to get negative 4. Well, the factors of negative 21 are negative 7 and positive 3, or it could be negative 3 and positive 7. Well, it's a little bit of trial and error in order to first figure out which one we need. If we tried negative 7 and positive 3, we always want to check our work. So let's take x times x, that's the first term. It's like using the distributive property. That's how we get x squared. We take the outside term, x, times positive 3, which is positive 3x. And then the inside term, the I in FOIL, is negative 7 times x, which is negative 7x. So when we have x squared is the first term, the outside term is positive 3x, the inside term is negative 7x, and then the last term multiplied together is negative 7 times positive 3, which is positive 21. So when we check our work, we end up getting back to what we originally started, because positive 3x plus a negative 7x is a negative 4x, which can be combined together because they're a like term. So we know that our final answer is going to be x minus 7 in parentheses times x plus 3 in parentheses. Or if you wanted to write it as x plus 3 first and then x minus 7, that would be fine too. So either one of these two answers is correct, because the only thing different that we're doing for those is using the commutative property, where we can switch what's in the parentheses. We can write it first rather than second, or second rather than first. In the next example, what we're going to talk about is factor by grouping. Well, the question says to factor completely, and we have x cubed plus 3x squared minus 5x minus 15. But when I write this, we can do it when we have 4 terms, Because I look at the terms and I can group, as long as they're written in descending order, the highest term first, followed by the next highest term, and so on down the line. If we look at x cubed plus 3x squared and put them in parentheses, and then plus, and then in another parentheses, negative 5x minus 15 in the second set of parentheses, I see that I have a greatest common factor for both sets of these parentheses. The greatest common factor in this set of parentheses, the first set, is x squared. X squared goes in evenly into x cubed and 3x squared. So I factor out that greatest common factor as x squared, and I'm left over with x plus 3. So when I distribute back out, I can check my work to make sure that I get back to where I started. On this second one, I have a greatest common factor of negative 5. Negative 5 goes into negative 5x and also into negative 15. And I have x plus 3 left over. So I can distribute back out negative 5 times x is negative 5x, and negative 5 times positive 3 is negative 15. So I can check my work. Now factoring by grouping says that as long as I have the same thing in parentheses, it has to be identical, then I can rewrite it as x plus 3, and then I can combine what's on the outside of each one of those into another set of parentheses, and then I'm multiplying them together. So I have x squared on the outside and negative 5, and I put them in one set of parentheses and I multiply them. So final answer is x plus 3 in parentheses times x squared minus 5. Or if you wanted to use the commutative property, you can do so, and you'd have x squared minus 5 in parentheses times x plus 3. That would be the other final answer.